Hello student, today we are going to learn the new point from atomic structure and wave mechanics, that is Compton effect. Now the Compton effect is a phenomenon in which when monochromatic X-rays are allowed to fall on a light element like that of carbon, an electron was ejected and X-rays get scattered at an angle theta with longer wavelength. This increase in the wavelength of X-ray after scattering from the surface of an object is known as the Compton effect. Now this effect was given by a scientist, that is Arthur Compton. He performed the experiment with that of the monochromatic X-rays. Monochromatic X-rays mean the X-rays are having the same wavelength. No doubt X-rays are electromagnetic radiation. That means it consists of bundles or packets of energy. When such X-rays are fall on a light element like that of a carbon, what happens? The electron get ejected, and after the collision with that of the element, the X-rays get scattered, and after scattering it is found that the wavelength gets increased. That increased wavelength of X-ray after scattering from the surface of an object is known as the Compton effect. Now the X-ray gets scattered with an angle theta. That theta angle is called as the angle of scattering. Now Compton explained this effect with that of an experiment. The experiment is very simple, like that of the marbles or two balls. If one ball is stationary and if you hit another ball to the stationary ball, then what happens? The stationary ball moves into one direction and the hitting ball moves to the another direction. But what happens? The stationary ball moves to one direction, no doubt, but the moving ball or the striking ball moves with a slower velocity of that of the previous velocity. Now same thing happens in this case also. What happens if X-rays of wavelength lambda, these are the incident X-rays, fall on an element? The electron from that element get ejected. That electron is called as a ejected electron, and X-ray gets scattered with an angle theta. Now what happens? The sum of the energy of these X-rays consist of the photon. We can say that the energy of photon is utilized to move that electron from the element, and if the energy of photon decreases, its frequency decreases, and if frequency decreases, then the scattered radiation is having the lower energy. If the energy is lower, frequency is lower, the wavelength will be the increased. In this way, the Compton explain the Compton effect. Now, by considering the collision between the photon and electron, he gave an equation. That equation for the change in the wavelength or increase in the wavelength d lambda. This d lambda is called as a Compton shift or a wavelength shift, is equal to lambda dash minus lambda. Lambda dash is a wavelength of scattered radiation and lambda is a wavelength of incident radiation, is equal to 2h upon m into c into sine square of theta, where h is the Planck constant, m is the mass of the electron, c is the velocity of light, and this theta is the angle of scattering. Now this equation mathematically can be rearranged. D lambda is equal to lambda dash minus lambda is equal to h upon m into c into bracket 1 minus cos of theta. Suppose this is the equation number 2. Now if you see this equation, this Compton shift or the wavelength shift is depends upon all these factors. Here is the h, m, c and theta, but there is no factor which shows the characteristics of incident radiation or the scattered radiation. That means this wavelength shift is not depend upon the incident radiation, that is the nature of incident radiation. Also, there is no any factor which represent the nature of the element. That means this wavelength shift is not depends upon two factor, which is that factor, that is the nature of element and nature of incident radiation, but it depends upon only one factor. What is that factor? H is the constant, m is the constant, c is the constant, only variable factor is the theta. That means the scattering wavelength shift is depends upon only the angle of scattering. Now let us say how that wavelength shift or scattering angle, wavelength shift or Compton shift, it depends upon the scattering angle theta. Now let us see the first case in which the scattered radiation is parallel to the incident radiation. In this case, theta is 0, that is scattering angle is 0. When scattering angle is 0, then cos of 0 is 1, so that this equation 2 becomes wavelength shift is equal to h upon m into c 1 minus cos of theta, h upon c 1 minus cos of 0. Cos of 0 is 1, therefore h upon m into c 1 minus, instead of cos of 0 is 1, 1 minus 1 is 0, therefore all the term becomes 0. In this way there is no wavelength shift or there is no Compton effect when the scattered radiation is parallel to the incident radiation. Now the second case, in this second case the scattered radiation is perpendicular to the incident radiation. In this case theta is 90 degree, the cos of 90 is equal to 0, so that the equation 2 becomes wavelength shift is equal to h upon m into c 1 minus cos of theta, h upon m into c into bracket 1 minus cos of 90, h upon m into c into bracket 1 minus cos of 90 is 0, therefore this becomes 1 into h upon m into c. Now in this case, if you put the value of h is the Planck constant, that is 6.626 into 10 to the power minus 34 joule second. M is the mass of electron, it is 9.109 into 10 to the power minus 31 kg. This is the velocity of light. Its value is 3 into 10 to the power 8 meter per second. If you calculate approximately, it is equal to 0.0242 into 10 to the power minus 10 meter. Now 10 to the power minus 10 meter means the angstrom, therefore we can say that 0.0242 angstrom. If this is 10 to the power minus 10, if you shift this digit to the right side by means of decimal to the right side by means of 2 digit, it will become 10 to the power minus 12, and therefore it is 2.42 in picometer. Pico means 10 to the power minus 12. This indicates that the wavelength shift is there, and that wavelength shift is depends upon the angle theta. Now the third case, in this third case the radiation is scattered in the direction opposite to the incident radiation. That means the direction of incident radiation and the scattered radiation is exactly opposite to each other. At that time angle is 180. In this case angle theta is 180, therefore cos of 180 is minus 1, so that equation 2 becomes E lambda is equal to lambda dash minus lambda is equal to h upon m into c into bracket 1 minus cos of theta is equal to h upon m into c 1 minus cos of 180, it is equal to h upon m into c 1 minus cos of 180 is minus 1, therefore it is minus into bracket minus 1. Now this minus becomes plus, and therefore h is equal to m into c 1 plus 1 2, therefore it is equal to 2 into h upon m into c. D lambda, that is wavelength shift, is equal to 2 into h upon m into c. If you put the values we will get this equation, that is 2 into 6.626 into 10 to the power minus 34 joule second. This is the value of Planck constant. Now 9.109 into 10 to the power minus 31 kg, this is value of mass of electron. 3 into 10 to the power 8, it's is the velocity of light. The value, if we calculate it, it is 2 into 0.0242 into 10 to the power minus 10 meter. If minus 10 meter is converted into angstrom, then we will get this value, and if we convert into the picometer, then it is 4.84 picometer. In this way, we can say that the value of wavelength shift or Compton shift, it depends upon the angle of scattering theta, which can be explained with the help of 3 different cases. Now this is about a Compton shift. Thank you.